is Mark Shelton, and this is a presentation on herpes simplex virus 1. So in order to taxonomize this virus, it's put in the order Herpes virales. It's in the family Herpes viridae. Subfamily is alpha herpes virinae. Genus is simplex virus, and the species is human alpha herpes virus 1. So you can see here that the common name is usually kind of a combination of this genus here is a simplex virus, and then this number 1 here, which is in the species. The International Committee on Taxonomy of Viruses, or is the organization that taxonomized this, and they're just trying to mirror the Linnaean classification of living things to viruses, which are of course non-living. So it is a virus. The disease it causes is herpes. It's mostly associated with oral herpes, but it can also be associated with genital herpes less commonly. There's many presentations, so you can also have herpetic psychosis, which is usually involved with hair follicles. So if the virus gets transferred to a razor and then say you cut yourself with that razor, then you would get that. Herpes gladiatorium is associated with sports, so it can kind of occur anywhere on the body, and usually the presentation is going to be a matted cluster of blisters in that area. Herpetic whitlow is generally associated with the skin around the fingernails. Ocular infection, of course, is going to be the eyes, and then herpes encephalitis. And so if you have ocular infection, you're going to have things like watery eyes, you're going to have just blurred vision, blisters around the eye. If you have herpes encephalitis, that's going to be associated with brain inflammation, seizures, fatigue. And of course, you can also give this to children too, so that would be neonatal herpes, and that can lead to miscarriages and early delivery. So if you look here on the right side, you can see a picture of the virus. It is a icosahedral capsid, approximately 100 nanometers in diameter. It does have a spiky envelope, and it is a double-stranded DNA virus. So the portal of entry, it does, as you can see on this right-hand picture, it can enter the eye, it can enter the mouth, it can also affect the urogenital tract, and the skin as well. So lots of portals of entry. If you do get it in the mouth, usually, obviously, the classical symptoms of herpes are going to be the red, itchy blisters, and then they do usually crust over in about a week, and that's when things start to heal. The virus does replicate at the point of infection, and then it spreads retrograde flow down the axon to the dorsal root ganglion, where the latency period occurs until then finally you are going to have some type of stressor or something that's going to bring that virus into an active state. But there's no getting rid of the virus. It's there forever. So it is important to note that 70% of encephalitis cases untreated can result in death, and when you have ocular herpes, it can lead to corneal scarring and also blindness. So a third of the Earth's population does have the virus, HSV1 at least, and so the virus is very widespread. In order to prevent the virus from infecting you, you would want to limit sharing cups, silverware, or any potential source of contamination of other people's bodily fluids. You want to wash hands frequently. You definitely don't want to touch any of the open sores, and you want to, if you are having sex, then have safe sex practices. Treatment would be antiviral medications like acyclovir or valacyclovir, and these also come in creams that you can topically apply to the skin. So the reason why I chose this is because I think that it's interesting how many people are infected. I didn't realize that it was quite that many. I knew it was a lot. Also, there's an enormous amount of presentations, which I think is interesting. And there is no cure and there's no vaccine. And if you look at the right-hand side, the reason for why I think the virus is so interesting is because it's very good at evading host immunity, and a lot of viruses are. And so if you look at the bottom here, you have interferon promoting genes, and interferon is just a way for the body to engage in pathogen clearance of viruses. And then you have all of these innate signaling mechanisms, such as like cGAS and RIG-I and MDA5 and toll-like receptors that reside in endosomes. And these are ways of recognizing viruses and then engaging in these downstream signaling pathways that lead to the promotion of interferon. And you can see all these green points of intersection, the virus is interfering with that. So the virus is just really good at preventing interferon from getting created. And here is my reference page for all the information in the presentation.